Hello everyone, I'm Armin Zahra, an aspiring astronomer, and welcome to episode number 7 of Cosmic Conversations, a series where I have the privilege of speaking with scientists, researchers, engineers, and innovators who are expanding our understanding of the universe. Through these conversations, we explore their research, career journeys, and the ideas shaping the future of space science. Today, we have an extremely special guest, Miss Ashley Walker. Miss Ashley, can you please introduce yourself?
Hi, sure. My name is Ashley Walker. I am an astrochemist and planetary scientist. I received my bachelor's degree in chemistry from Chicago State University in the United States. I am currently an incoming PhD student in planetary science at Hampton University in the Department of Atmospheric and Planetary Science here in the US.
Wow, that's really impressive. So, my first question was that your research spans the atmospheres of Titan, Uranus, and Neptune, each with remarkably different chemical environments. So, how has studying such diverse planetary atmospheres changed the way you think about the universal chemical processes that shape the planetary evolution?
So this question is very interesting because when I initially studied Titan, I just thought like I just always wanted to study Titan, and when I then start studying Neptune and Uranus, it actually was a building block to study those colder atmospheres. And so when we think about like those three in particular atmospheres, these can help us expand to exoplanets and what we think could happen because as you know, there are things, and if folks don't know, there are things called sub Neptunes or mini Neptunes. These are planets that are a little bit smaller than your regular average Neptunes, but they also mimic and have similar bodies as what we can see on Neptune and Uranus. Now, we haven't been to Neptune and Uranus in a very, very long time, and we're hoping that we can do so in the next several years, in the next decade or so. But with Saturn's moon, Titan, we do have a mission called Dragonfly that will be going out. Later this decade. I want to say they pushed it back and played with it about either next year or the year after next. Um, However, when we look at what's happening on Titan, this can help us understand a lot of other unknowns that we didn't expect to see or we didn't pretty much understand because when we think about Titan, we think about earlier, and that helps us a lot better to understand our own early Earth back in the day.
Right. And my second question was that you have worked across laboratory, astrochemistry, observational research, and NASA missions. So, which type of evidence has challenged your assumptions the most? And how do you reconcile differences between laboratory models and real planetary observations?
So um, I would have to say the one that is most challenging is lab, mainly because a lot of times you just don't know what you're going to expect, what new challenges in the lab. So generally, for most lab scientists, as we all know, that if a piece breaks down and you don't have that piece, it can take up to 3 months to a year to who knows to when you're going to get that new piece working. But when we compare some of our results, so generally some of our results when we replicate it comes from observation. And so, and it also coincides with what we did theoretically, what we did computationally, what we thought about. So when all three of these things go hand in hand, they help us understand a lot better about what we can visualize when it comes to these types of atmospheres. Um, but overall, I would love to just say that like I love lab work, number one. I do love coding. Um, with observation, it's a little bit more difficult because you have to stay up at night at sometimes, and it depends on like when you're observing and your observing times and stuff like that. But I traditionally um, love seeing how can we fix this? How can we fix or get to this particular interesting thing that we don't know about? Because it's not necessarily a quote unquote problem. It's just that something that we may not have thought about.
Yes, I agree with you. And the next question was that when you are explaining planetary atmospheric chemistry to a general audience versus writing it up for a peer-reviewed journal, what's the biggest thing that gets lost in translation? And is there anything you wish more people understood about how uncertain or provisional planetary science findings actually are?
So a lot of times we use a lot of big words that can get lost in translation. And sometimes, if we're talking to a general audience or we want to explain this for example, if you want to explain this to your 8-year-old cousin or your grandma who is just like, oh, I never thought about that. So a lot of times what we tend to do is we overshoot it. And so, because not everybody is going to understand what we're saying. So, in some cases, we do have to think about our audience and who we're speaking to. This way, that we want to continuously attract the readers, but not just the readers. We want to attract everyday people towards this type of work. Can you repeat the second question?
Yes. Yes, of course. My second question was that is there anything you wish more people understood about how uncertain or provisional planetary science findings actually are?
Yeah, the one thing, everything takes time. And sometimes it may not go as fast as you wanted or as like, oh, we can get this right now. Sometimes it takes a little bit longer than what we generally expected. That's some of the things about our findings. And sometimes you'll find something completely different from what you're actually looking for, or it may not be the result that you were hoping for. And that's okay. That's all a part of science and making sure that um, when you get the unexpected results, you then want to make sure, okay, well, how can I turn this into a positive or something that can confirm someone else's um, ideas? And that's okay that you want to do that. So when we think about some of these findings, when we think about just a lot of these things, we want to make sure that we're okay with whatever happens in terms of science.
Right. And now let's talk about Black in Astro. So, Black in Astro has become much more than a visibility initiative. It has fostered mentorship, networking, and community. So, looking ahead, what do you think the next phase of building a more inclusive astronomy community should focus on beyond representation?
Beyond representation, the astronomical community right now, where we are in the state of particularly the U.S. and how it is now, we're seeing how everything is going globally. We want to make sure that we continue to develop partnership. Here in the U.S., we have a funding crisis, and many people who want to come over to the United States. Sorry about that. um, right now we are in a state where we need partnership or we need each other, and so rather than outside of representation, we do need collaboration, regardless of where someone is from or what they look like. because everyone brings something to the table. Everyone is valuable. Everyone is needed to continue to push the boundaries of science.
Yes, that's really great that you want everyone to be included. And the next thing is that you have built a career that spans laboratory experiments, spacecraft data, and public communication, fields that don't usually train people in the same skill set. Was there a moment you had to teach yourself something completely outside your original training? And how did that change the kind of scientist you became?
So I was fortunate enough to have mentors who could train me on certain things because during the time of my undergrad career and also even in my graduate studies, I think that sometimes we have to go seek out the people that we need. Um, and that's okay. It's perfectly fine to do so. And then also, people would introduce me to people as well. Like, hey, I think this person might be good for you. Um, and that also helped me build where I needed to be. But I also envisioned certain things for myself. Like, I knew that, for example, I did not want to continue a PhD in chemistry. I knew that. I knew that I wanted to go and push the boundaries and go get a degree in planetary science or astronomy. That was something that I knew from, I think, my after my first internship. I knew that. I was just like, I want to do this thing right here. And there were people who are like, you can absolutely do that. So as long as you have supportive people who can give you an extra push, but you also have the drive and courage to do things independently, I think that that can go a long way.
Yes, I have also experienced that if people are there to support you, then you can achieve a lot. Now, my next question was that is there a specific data set, such as from the Cassini, Voyager, or a current mission that you keep returning to because it still hasn't given up all its answers? So, what do you think it's still hiding?
Oh, that's a loaded question. Right now, no, at the current moment, because I'm actually just taking from what previous people have written in papers, because we don't have enough data on Neptune and Uranus, and we haven't been there in a very, very long time. But I do think that I'm still very much interested in seeing the clouds and the hazes of Neptune and Uranus and how they're interacting with each other. This is still a mystery there's a lot of mysteries for the ice giants, as I call them, the ice queens, that we just don't know. And I think that I'm very interested to see what secrets they possess that we can reveal in the future. That I am very excited about.
Yes. And my last question was related to light pollution. So, astrochemistry relies on detecting incredibly faint spectral signatures from molecules in space. And as urban areas transition from sodium lamps to blue rich LEDs, how has the changing spectral composition of artificial light affected our ability to detect these molecular fingerprints? And also, are there any particular wavelength ranges or molecules that have become especially challenging to observe?
So one thing that I did note that, like, especially I live in a city, so I live in Chicago here in the US. And so it is very challenging to see certain things. So, for example, there's been quite a few times where we had the Northern Lights, and me and my fiance were chasing the Northern Lights. But we didn't see it. Like, it was so disheartening. Everyone else apparently ended up seeing it but me. And so I was just so sad about that. And so those are certain things when it comes to light pollution that I think that can be extremely challenging, especially just for everyday people. So one of the wavelengths that I believe that we don't have enough studies about that I had recently found out was in the UV. And so that's something that's actually on my to-do list. So, like, all right, let's see how we can figure this out in the UV, because a lot of studies, because depending on which type of studies we're looking at, whether it's the moon, Mars, Venus, etc., we may not have as much data as we would like. And so, um, all in all, I am very, very pro dim the lights, so that we can see what's actually happening. Because outside of um, light pollution, we also have a bunch of satellites in space that are also that are causing debris as well, which can also cloud our judgment and things of that nature. And so those are some things that I do know some folks that are working on space debris, which can help us understand what's happening a little bit better.
Right. So that's it for the interview. And this has been such a rich conversation. And thank you so much for taking the time to walk through all of this with me.
Absolutely.